Hello, can everyone hear me? If you can hear me, just send a message to the GoToWebinar chat. Great. All righty. So we're going to get started. Welcome to session 2 or maybe session 20, depending upon what group you are in. It is a merged class. We have some folks that are from the previous class that have rolled over. Happy Thursday. We're going to go ahead and get the ball rolling. So first and foremost, you guys are supposed to be working on your Java Udemy class. Yeah, the guy that has a really funny voice. You guys need to get used to it because the Udemy is it's not a short one. It goes roughly 16 hours. 16 hours, but when you rewind and try to do things like he's doing it, you really end up spending about 32 or maybe even 40 hours on the effort. So it's there for a reason. We're building skyscrapers here, and for those of you that don't know, you start building a skyscraper by digging down into the ground, right? So you dig down into the ground and lay that foundation. We are laying a foundation of object-oriented programming and some very, very clean, concise fundamentals for you guys to start getting involved with software development the right way, all right? It's not just okay to be a software developer. You have to learn how to do it the right way and the way that all these companies want it. Because if you can do it the way they want it, then the world is your oyster. You can work wherever you want. You can work at home in your underwear and get paid 6 figures, have lots of time to spend with your family, all that fun stuff. But really, it's directly proportionate to how hard you work. Pretty interesting stuff. Directly proportionate to how hard you work and what you put into your mind. So we are going to give you the tools and the material that you need to cram into your mind. And if you do that correctly, you're going to win. We see thousands and thousands of jobs every single day. So we know exactly what's in demand, and you're going to come out of this program super fresh, and clean, and relevant, right? And over time, you are going to learn how to improve your own relevance in the marketplace. You're going to learn how to teach yourself what the trends are and train yourself on these new trends so that you continue to stay relevant. Technology shifts roughly once every 18 months in software. Every 18 months, there's another paradigm. I would actually say now it's like every 14 months. There's a new paradigm out there. There's a new programming interface. There's a new thing out there that you need to be thinking about and determining whether or not it'd be valuable to your career. One key way of determining what's in demand is to do some research on up and coming technologies, and then just go to Dice or Indeed and search on those technologies and see how many jobs pop up. It's very simple. You do this over the course of a month, a week, a year, and you'll start to recognize trends in different technologies. So the more jobs you see in a particular technology, the more likely you should probably be trying to pick that technology up. All right, so before we did a quick little overview of what's going down, how this whole process and how this whole program works, right? Now today we're going to talk about one of the single most important elements of all of this, and that is the Sdlc, which is the Software Development Lifecycle. I'll pause right now and state this. Everyone in this class is responsible for taking notes for the class. Everyone here is responsible for taking lecture notes, and then immediately after the lecture is done, sending them to the piazza. That lets us know exactly what you heard, what you didn't hear, and whether or not you were really paying attention to what we were saying. So that's number one. Rule number one is every lecture, immediately after the class, everyone is required to send their notes to the Piazza. All right? So I want to see copious, beautiful notes that are well organized and ready to go. All right? 2, we're going to give you a decent amount of vocabulary. That vocabulary is some stuff that you're going to have to remember. It will be vocabulary plus a number of interview questions that we're going to start on early. A lot of these materials, a lot of these resources are already in the Piazza. So you'll see as we trace through these things, you'll actually see recordings of previous lectures. For instance, the lecture 2, the software development lifecycle. You'll see all of these in there. So what we're going to do is go through the software development lifecycle, or SDLC. You guys can confirm in a second whether or not you can see my screen. Let's see here. Can y'all see my screen? Got it. So I will address any of the access issues related that you see. You can also reach out to Brooke or enrollment or anybody about any issues that you're facing, administrative or other. So software development lifecycle. There's some key points that you guys have to know. So again, we're not going to play around here. We're going to give you the material that you flat out need to memorize. You just need to memorize it. Don't spend all this time even trying to understand stuff right now. Just memorize it. Because part of getting in the door and part of understanding how to function in an environment is being able to just regurgitate information as if you were reading a book. It is extremely valuable when you can clearly and concisely speak to a particular topic and stop. Okay? Not mumble around saying, oh, well, I think it's this, I think it's that. No. SDLC is this. Here's what the primary components are. Here are the 2 ways that you can build, code, and deploy software. Here are the positives and negatives of each approach. And because I know all of this stuff, it makes sense for us to go in that direction. Right? You, in many cases, as you mature as an engineer, will be the go-to person that folks will look towards for guidance. So in that regard, you need to be very definitive and not wishy-washy in terms of the way that you speak. The only way you get there is by getting a command of the material and conquering it and knowing it, dissecting it and planting it into your mind in a manner that is, indelible, and in a manner that is literally like it's part of your permanent memory. That's where you have to be with some of this stuff. And again, you don't have to memorize all of it, but we're going to be very, very clear on what needs to be memorized. And the rest of the stuff you can just research on Google. All right. All right, so we've level set. Software development lifecycle. Let's talk about that. Now, we believe that software runs the world. Why do we believe software runs the world? Because it really does. I mean, your phone, the power grid that powers your house, the electricity grid, your computers, your cars. I mean, these are all computers that are run by software, right? Your cable service, all the things that run your job, your HR software, your whatever the logistics software your company might use. All of these things, the website, your company's mobile app, these are all software. This is all software that's been developed, and as the days go by, these companies have a larger and larger dependency on software. So in that regard, we believe software runs the world. So if you can run software, guess what? You can run the world. If you can build that which you conceive in your mind, then, you might be the next Zuckerberg. Facebook is all software. The guy's 35 years old, worth $70 billion. He just conceived something. So there's a lot of amazing things possible with software nowadays, and it's only getting, the opportunities are just getting bigger and bigger. Anyway, but it all starts with the software development lifecycle, having a framework and an understanding for the general process that is used to develop software. There is a structure here, right? Imagine building a software application like building a skyscraper. There is a framework, there are blueprints, there is a process, very methodical process that is executed in a certain sequence to get this building up and running and built to spec. Think of your software application, whatever it is you're trying to build, as just that, as a skyscraper. And it'll make a lot more sense in a little bit. Anyway, SDLC is a framework that describes the activities performed at each stage of a software development project. Here are the Sdlc phases. Make an acronym out of it. RDDTIM. RDDTIM. You make up a funny acronym. You could just memorize the letters. Requirements gathering. What is this thing going to do? Design. Okay, well, let's draw some boxes and arrows and build some initial models and determine what this thing is actually going to do on paper. Development is actually building it, writing code. Testing. Does what we build work? And if it doesn't, why doesn't it? If it doesn't work, what do we need to do to fix it? And that means you might need to do more development, and you could end up in a number of loops between development and testing until something works. Implementation is making the application live. An application has now been developed and thoroughly tested. Everything works like it's supposed to. Now it's time to implement it, meaning make it live, make it available to service customers, or make it available to do what it was intended to do. At that point, that application is in what we call production. It is in production. The code that you've been building for all this time, the cool app that you've been working on for all this time, is now finally live and able to service requests. That's implementation. It's finally gotten out there. And that takes a lot of energy usually. Maintenance is maintaining that which you've built. Software updates, security, security patches, anything, or code updates itself. Maintenance is anything connected to maintaining your application and growing or changing it if it has to be changed. Okay? This is where between these steps, between these individual phases, is where literally 99.9999% of all tech jobs lie. Now, we're primarily talking about development, but you need to be fully aware of all the other pieces, because in your projects, in your tech projects, when you have these great high-paying IT jobs, you're going to be dealing with people from each of these phases. You're going to be dealing with people from requirements gathering, and you might be one. You're going to be dealing with people from design. You might be one. You're definitely going to be a developer. You're going to be dealing with folks from testing, or you might be building your own test. You're going to be dealing with implementation people, which are generally what we call systems administrators. You take the application that you've worked and slaved to build, and they deploy it into production. Maintenance is also systems administrators. They're not developers. Their job is to see the full picture and troubleshoot if issues come about. Okay, so it's a different kind of personality at every single one of these tiers. I think some of the craziest people are developers, generally, because they realize after some time that they have a lot of power. And if they stop working, things stop happening in the company. So they tend to get a little full of themselves sometimes. But it's a good thing. It's hard to write good code. Anyway, SDLC phases will continue on. This is a more detailed diagram of what happens from project initiation all the way to release of the product. Okay, so there's a number of different steps here. You see the project initiation, they're developing estimates, they're trying to figure out what requirements are, are there just going to be diagrams, we're going to build flow charts, we're going to build functional requirements, technical requirements, statement of work. The statement of work ends up creating some type of physical document that is now available that explains everything that needs to happen. Then you go into internal, external design, design review, more details on design, prototype, code review, system test, operational acceptance. These are some of the phases that do happen. You don't have to memorize all of these. You just have to remember the ones that I gave you a little bit earlier, which are the requirements gathering, design, development, testing, implementation, and maintenance. Somebody on the street or in an interview asks you, what are the phases of standard Sdlc phases? You need to be able to regurgitate that. I'm sorry, there's really no way around it, okay? You can't say, oh, I understand. You should just be able to rattle it off, okay? Now, just to be clear, I did not say you have to memorize this slide. You don't have to worry about this slide. You get your little acronym, and then you go Google the rest. So now we're going to talk about Sdlc models, software development lifecycle models. It's important that we understand the phases, which we mentioned before, but we also need to understand some high-level models that are commonly used in these companies. Software development experts and architects over the years have formulated these models for as optimal as possible to develop software efficiently and effectively and hopefully under budget. Now, here are the reasons for using Sdlc models. Number one, they give you the basis for project planning and estimating cost and scheduling. It's a big deal. Two, you're going to give a framework and a standard set of activities, a standard set of terminologies, activities, and deliverables. That's how you level set across a group of people that are working towards the same thing. Three, it provides a mechanism for project tracking control. The model will drive a lot of these things. Four, and it's going to increase the visibility of the project progress to stakeholders. What are the advantages of choosing an appropriate Sdlc? I mentioned before there are a number of them. We'll talk about them. But you got to pick the right one. In order to pick the right one, you need to be aware of the strengths and weaknesses of each. You need to have them memorized. And then you need to be able to communicate the differences between the models. And then from there, you can make a decision on whether your project needs to go in one direction or the other. So the advantages of picking the right one. Number one, increase development speed. That's number one. You want to write good code fast. Generally, that's hard to do, but if you have the right approach, you can get it done. You want increased product quality. You're going to get improved tracking and control of issues and things like that. These applications are moving targets usually. They're growing as you're developing, more features are coming on board, and it's a very dynamic process, software development, especially when you're talking about a large team of software developers. Decrease project management overhead. That's a big deal. That's connected right to the dollar, and the dollar and the cost is the biggest issue in just about every software development effort. So what are the common lifecycle models? Number one is waterfall. Two is spiral iterative. Three is agile. So note to you guys, remove the second option, spiral iterative. You don't even need to be able to speak to that because it's irrelevant at this point. Your key points, if you're in an interview and someone says, hey, which Sdlc model do you prefer? And you're going to be like, well, okay, well, of course there's agile and waterfall. I prefer agile. We're going to talk about what those two are and what the differences are between the two. Waterfall model is very linear. You are going to do analysis, design, testing, deployment, and maintenance all the way through. Notice how deployment is at the very end. That means it's very well possible for you as a developer in the waterfall model to do your analysis, design, do development, testing, deployment, and you're building towards one final goal. You could go down this pathway and be down that pathway for months and months, finally get to the deployment phase, and your customer's pissed off because what you deployed is not exactly what they wanted to see. That's one of the problems with the waterfall model. If your requirements are not fully vetted and they're not fully created, then there's going to be some problems. Because the waterfall model doesn't really allow you to kind of go back, so to speak. It's about building up for some big bang presentation where you show everything that you built and hope that the customer likes it. That's why waterfall is generally not recommended. Agile is completely different. Now, more information about the waterfall model. The oldest and most well-known software development lifecycle model. It follows a sequential step-by-step process, meaning it's very linear. There's no, multiple things going on at one time type deal. It's very linear. Systems that have a well-defined and well-understood requirements are a good fit. That's right. If the customer knows every single thing they want, we'll go waterfall. If they don't, then you're going to have to do a discovery of some sort. And that's when you start looking at other software development models. You need to know this stuff. What are the strengths of waterfall? Number one, it's easy to understand. Two, you're going to get structure, particularly for inexperienced staff. Three, milestones are very well understood. You understand what needs to be delivered and by when. Four, there's a requirements stability. You have the ability to kind of stabilize on the set of things that you want to deliver, as opposed to it being in flux and changing all the time. Five, good for management control. That's a big deal. You need to be able to provide controls for management and for leadership to get involved and plan and track and things like that. And ultimately, it works well when quality is more important than cost or schedule. If you've got plenty of time to burn on a project, then generally you're going to pick a waterfall method. So we're going to go into Agile, and then we're going to go into a little bit of Q&A, and then get you another assignment to start working on. So, tying on to the strengths, there are weaknesses to waterfall. Number one, all requirements must be fully specified up front. That means every single thing that you are going to need for that application, resource-wise, and all that other stuff, all considerations, you have to put all that energy into getting these things up front. Okay? So you got to put a lot of energy into getting these things up front, which can be a major problem when the customer doesn't know what they want. The problem with waterfall is you can give a false impression of progress, because in the waterfall model, nobody is looking for code in the very beginning. Nobody's looking for something that works in the very beginning. They're just relying off what you're saying. And since it's waterfall, it just makes sense. That's what's happening. It's waterfall. So they get it. They get that they're not going to get any information this early, and they're fine with that. The problem is towards the end, if you're not building exactly what they asked you to build, they're going to be very mad. Software does not really reflect the problem-solving nature of software development projects. When you're in waterfall, it doesn't allow you to inject new features and new functions in along the way. You start out with a set of features that you're trying to build in the very beginning, and you just run. Now, it doesn't allow you to be dynamic and adjust to industry trends either. So making changes costs a lot of money when you're utilizing the waterfall methodology. All right? And ultimately, there's a little opportunity for the customer to get feedback very early. When are you going to use a waterfall model? I'm sure you guys have figured it out. When requirements are well known. That means everything that you want in the app is done. You already know it before the developers wrote one line of code. You know everything that you want. Product definition is stable. Everything is clear. There's no what ifs. There's no nothing. There's no confusion over any aspect of the project. That's when you go waterfall. It might be a new version of an existing product, or it could be you porting an existing product to a new platform. So we'll go over some of that terminology. Don't get too discouraged by some of it if you don't understand it. Just take notes and look these terms up. We're not going to go over the spiral iterative. We're going to go now into the agile model, and look at these little loops here. These are called sprints. Basically, in an agile model, you have the ability to do some discovery, you can do some design, development, and test into these very tight time frames. So you're going to assess what needs to be built, you're going to start building, you're going to test, you're going to make sure it all works in a full cycle. You're not going to wait to the very end of the project to start doing this. Agile model breaks things down into little sprints, where in that sprint, you're just coding like crazy to deliver a certain core set of functionality, and then you stop. You sprint and stop. And during that sprint, you're getting all your tasks done, you're executing, getting all your programming done, and then you stop. Because it's time to stop. The sprint is over, and you need to show what you've done. So design, discover, test, develop. Those are the standard features or standard areas that are associated with an agile approach to software development. What's going on? It allows you to speed up or bypass one or more lifecycle phases. You can, if you have an efficient agile approach, you can really get a lot of cool stuff done very quickly. It's less formal and reduced in scope. It's really more about execution and getting things done in a very tight time window. That time window does not change. So it's used for time-critical applications, as I just mentioned, and it's also used in organizations that employ disciplined methods. There are a number of different agile methods: rapid application development, RAD, Scrum, XP for extreme programming, adaptive, feature-driven, crystal clear, rational, unified process. You should know about 3 of these. You should obviously know Agile. You should obviously know Scrum. You should know feature-driven development, and you should know extreme programming. Those are the primary 3 Agile methods that you should be aware of. Scrum, note to all of you, Scrum is the primary, actually most dominant flavor method of Agile that's being used in this world. So every company wants to be Agile Scrum. So the more additional information you can do personally, looking up some of these terms, the better off you're going to be. The Agile model strength. Number 1, you can deliver a working product faster than a conventional linear development model because you're thinking about all things for an entire sprint, not just the UI or anything like that. You're thinking about all things. So you have the potential to deliver a work product faster than conventional development model. You get customer feedback at every stage with the Agile methodology. That means you actually get customer feedback. When a sprint is done, you say, "Here, customer, here's what we got so far. Do you like it? What do you think?" When you're waterfall, you don't do that till the end of the project, and they can get mad. Who wants that? Who wants a mad, angry customer? Nobody. So no guesswork. No guesswork. That means there's no guesswork between the development company or the development team and the customer. There's face-to-face communication, and you're continuously getting input from the client, and that's very important. The Agile model weaknesses are: one, for larger projects, it's really difficult to judge the efforts and time required. You start turning a little bit on the larger projects. You actually, now, since in this case, another weakness is there's a very high chance that your project can go off track and go down these crazy rabbit holes, especially if your requirements are consistently changing. You have to be careful about that. Notice in the waterfall method, requirements are not ever changing. Okay, so they're static, they've been defined already, and now it's just time to write code. So that's it. That is a quick little rundown of Agile and Waterfall. I want to see if you have any questions. Fire off the questions in the Piazza. Sorry, not Piazza, in the go-to meeting control panel. Questions? Hope you guys got some good notes. We're looking forward to seeing good notes. All right. So it's 9:44 right now. What I want you to do is watch 3 videos on Agile. Watch 3 relatively short videos on the Agile methodology on YouTube. That is your assignment. Send a note to the Piazza showing the YouTubes that you watched and what you were able to pull from those. Does that make sense? Is everyone clear on the assignment? So we got some questions about the third Agile method, extreme programming. As far as the most, so Cody asked, what are the 3 methods? What 3 Agile methods are the most relevant? Right now, you're going to see Scrum dominates. Scrum dominates most software development shops. Scrum dominates. Remember, if someone ever asks you what's your favorite Agile methodology, you say Scrum. Agile Scrum. Extreme programming is sunsetting a little bit, but it's still very important. I think rapid application development is also pretty popular as well. More questions? Yeah, that's right. So we got some answers coming in from Lewis. That's good. Agile methods you talk. Oh yeah, the other. Well, the ones that I mentioned were extreme programming, Scrum, and then feature-driven development. Not much of a question. By statement, Scrum is the best methodology. That's correct. But for now, going through these the videos in Piazza. The videos will be in Piazza. It's going to be a couple of hours, but they will be in Piazza. Okay, more questions. Can you repeat the assignment? Again, your assignment is to go out to YouTube and look up 3 videos on Agile. That's your assignment. So it's 9:47. You guys can probably get 2 or 3 of those things done in the next. Literally, you'd be outside of class, but you can probably get it in the next 30 to 35 minutes. It's very doable. Okay. Oh, the videos are on Agile. So I'm going to text it to you, to all of you in the go-to meeting. 3 videos on Agile. Three videos on Agile in YouTube. You're going to check YouTube for 3 videos, and then basically take notes and send them in. That's your assignment. All right, so go ahead and knock that out. Make sure you stay on top of your Udemy class. There are going to be quizzes and tests coming along that way, so make sure you have it. All right. Yes, I want 3 videos and notes on the Agile methodology. That's what you send into the Piazza. All right. So I think we got everything for today. You'll also see this this particular presentation loaded up into the Piazza. Long story short, keep a strong mind, keep a good attitude, and keep pressing on, and everything will work out like it's supposed to. And you'll get all these things done. Okay. Excellent. 9:49. Go ahead and get your go ahead and start working on your assignment and working on turning it into the Piazza. More questions? No, there will not be any quizzes on the Udemy class. It's really just for learning. All those questions and things of that nature come from our side. There are no quizzes. Good. So you guys got everything you need. Go ahead and get started and finish your assignment and start submitting it in. Again, if you have any questions or concerns, you know who to email, primarily enrollment. And yeah, just take your time and execute. Make sure that you get the results that you sought out to get. All right. So get started. You'll see a recording of this lecture in about 30 minutes. Everyone will get a link to it. All right. And any additional questions you have, just send them to enrollment, or you could say, yeah, I think that's the primary email that I want you to send those things to, is the enrollment. Alrighty, folks. You guys have a good Thursday evening, good Friday. There's going to be some assignments around these things. So be on the lookout for the Piazza. Always be watching it, and help your other fellow classmates out as much as possible once we start getting into programming. Alrighty, folks. It's been great talking to you. You got through another session. Now let's get back to work, get your videos done, and get your videos done, and then also make sure you really plow through that Udemy course. All right, guys. Talk to y'all later. Bye.